All right, so apologies while I type, but this will make things really clear about, I hope, about what departure is. So I'm going to call this class reference current. All right, so I'm going to go down here and go A, B, C, D. Really simple. What? Auto format. Anyways. Okay. Wow. All right. So I'm going to make this really simple on myself. I'm going to go 10%, 20%, 30%, 40%. So from our reference models, we determined that there would have been 10% of class A historically under natural disturbance regimes, 40% of class D, and so on. All right, so I'm going to put in, I'm going to put in UN, uncharacteristic native. There would have been 0 of that on the landscape historically. So let's say that today we have no A, 30% of B, 60%, 60% of C, and then we have uncharacteristic. So this is 0 here. So to calculate this thing called vegetation departure, it's really simple and goofy. We take what's called the similarity between the two, reference and current, but I'm going to just call it min. So basically I'm going to take 0 from this one, 20 from this one. Whoa. Number lock didn't. Okay. 30 from this one, 0 and 0. So you take the least of the pairs, 0, 20, 30, 0, 0. Then you take the sum of that, which is 50. Then vegetation departure equals 100 minus 50. So in this case, equals 50. When LANDFIRE delivers a data set called vegetation departure, they deliver it in 2 ways. One is a data set called vegetation departure, which is each pixel gets a value from 0 to 100, which is what I just calculated. Corey also mentioned 1, 2, or 3.
So, quick question.
Yeah.
Find that
Which number?
the first.
The 100?
No, okay, you said you use that the number that you just calculated, right?
The 50?
Yeah.
Mhm.
What is that? That
50% of the area that
yeah,
is
okay,
not.
I got that piece, but what defines what class A is? So there's 10% of class A, but ultimately what defines what class A is?
The height and cover.
Right, so it's early successional.
Mm-hmm. I
And
think
that's for each pixel, so each species.
yeah, it's really a bizarre thing. I don't know where else in life we would do a math like this, where you take the least of these, then summarize them and subtract that from 50. But it took me playing in Excel like this a few times to believe that it worked.
So the higher the number, though,
The more departed it is. The higher the number, the more departed it is. So Mindy, I would encourage you to play around with this.
I don't want to.
Okay, we'll skip it then.
It makes my head hurt a little bit because the question is departure from what?
Departure from the reference values.
Right. But as I look at it on the landscape, is what am I identifying? What am I defining as my ideal condition? So, for example, I may have an aspen stand where I want it to be 50% C and 30% A. So we're looking at this grouse habitat thing. We're got that multi-standard early succession stuff,
Mhm.
and that's just making my head hurt. I really define what my optimal is, because we're not doing that. We're simply saying it's early succession, mid succession, late succession.
Earlier in your first question, you were talking a little bit about departure from the
I know.
historical interval, which is different than
Correct.
this.
It is, but it will put you into those classes based on that. And again, trying to define optimal. Because you have to define optimal to get a departure from where you want to be.
Yeah, and so that's where all the biophysical settings models came in. And you might decide that you don't like those or believe those. So you could do, we could just rename this and say that this is DFC.
You said, are you gonna regret asking this question?
You're there.
No, yeah.
Desired future condition. So you could use the same kind of math. And so so LANDFIRE delivers a data set called vegetation condition class, which is where they take that 100, the 0 to 100, break it into thirds. So each pixel gets a 1, 2, or 3. 0 to 33 is 1, 33 to 67 is 2, 67 to 100 is 3. Okay, so basically, the biophysical setting will get one value across its whole extent. Because this is calculated, this 50 is for this biophysical setting. So if we had, you know, I know it doesn't really work this way, but this is, we'll say this is my BPS, and we have my pixels.